Hello, 7th graders, and welcome to our first new lesson in Module 14 on Chapter 6.3. So notice we're starting mid-chapter. We already did the first half of Chapter 6 back in Quarter 2. So the first half of Chapter 6 was on writing and solving one-step equations. Now we're going to take it a step further and write and solve two-step equations. Before we jump into 6.3, there's a couple things we need to review. So the first thing I want to review is the objective. When we're solving for a variable, the objective is to get the variable by itself. What that means is if we have x in an equation, we're going to move all of the stuff by x, so whether it's multiplying, adding, subtracting, we're going to move that over to the other side so that we can get x by itself. When we move the other stuff over, we have to balance the equation. We also have to use inverse operations. So remember, addition and subtraction are inverse operations, and then multiplication and division are inverse operations. What that means is if we're trying to undo subtraction, we need to add. If we're trying to undo addition, we need to subtract. And same thing for multiplication and division. Also, when we're solving for a variable, we're going to use the order of operations. Since we're working backwards to get the variable by itself, we actually need to use the order of operations backwards. So remember, the order of operations is PEMDAS. Since we're working backwards, that means we need to undo any addition and subtraction first, then undo any multiplication and division. All right, so let's get started. In this example, we have 3x minus 4 equals 5. We're going to be using Algebra Tiles. So if you've never used Algebra Tiles, they look kind of like this. You're normally going to have one color representing positive, one color representing negative, and you're going to have different types of tiles for a variable and then for actual ones. So we have 3x minus 4. We would use 3 positive variables to represent the 3x. So that would be x plus x plus x, 3 positive tiles, variable tiles. And then it's minus 4, so we would use 4 negative 1 tiles. We would say minus 1 4 times. And then the right side is just 5. So then we have 5 positive ones. All right, so let's actually draw this out. I'm going to use bars for the variables. It'll be a little easier to draw bars than rectangles. So I had 3 positive variables, and then I had 4 negative ones. Those are more like squares. Pretend all of those are squares. Okay, and then on the right side, I had 5 positive ones. Okay, so another thing to review are zero pairs, or opposites, one positive and one negative, equals 0 when we add them together, so they cancel out. So remember, my objective is to get x by itself. That means I want to get one, let's write in black now, one of these bars by itself so I know what x is equal to. So the first thing I'm going to undo are the squares, and to cancel those out, I need to make these 0 pairs. So I'm going to add 4 squares here, and then these are going to cancel out. Because I added 4 to that side, I need to balance the equation and add 4 over here. Now I have 3 bars on one side and 9 cubes on the other side. I want to just get 1 bar. I want to know what 1 bar is equal to. So if 3 bars are equal to 9 cubes, I'm going to take that 9 and divide by 3. I know that that's 3, so that means each bar is equal to 3 cubes. So what that means in our algebra terms is that x equals 3. All right, our learning target today is actually to write two-step equations. So let's look at a real-life example and practice writing an equation to represent the situation. All right, so example 1. A one-year membership to Metro Gym costs $460. There's a fee of $40 when you join, and the rest is paid monthly. Write an equation to represent what you will pay monthly for the year-long membership. Write an equation that would help members find how much they pay per month. Okay, so we know in a year you're going to pay $460. But there's a fee of $40 when you join. That's a one-time fee. We're trying to find how much they pay monthly. Remember, there are 12 months in a year. So 12 times whatever they pay monthly, plus that one-time fee of $40, is going to equal 460. So to set up an equation, we're going to say 12 times whatever they pay monthly plus $40 equals 460. Running out of room there, but they also have that right here. All right, let's reflect on this a little bit. Why would this equation for finding the monthly fee be difficult to model with Algebra Tiles? Well, remember when we had equals 5 and we had to represent it with 5 cubes? I don't know about you, but I don't really want to draw out 460 cubes. Can you rewrite the equation in the form 52m equals 460? Let's think. Where did they get the 52 from? It looks like they're adding 40 and 12, which you just can't do. You can't add 40 and 12m. They aren't like terms. Sorry, those are not like terms, so you can't combine them. If this were 40m plus 12m, you could combine it to get 52m, but because one term has a variable and one doesn't, you can't combine them. They're not like terms. All right, and today we're not actually working on solving these. That's going to be in our next lesson in 6.4. We're just working on writing two-step equations to represent real-world problems. All right, before we check out our second example, let's practice with this up here. Billy has a gift card with $150 balance. He buys several video games that cost $35 each. After the purchases, his gift card balance is $45. Write an equation to help find out how many video games Billy bought. All right, I want you to try this on your own. Try to set up an equation for what he spent on video games, and then play it back and see if you got it right. All right, so first let's identify important information. He starts with $150. He buys several video games. That's going to be our variable. We'll just say V. And they are $35 each. After the purchases, he has $45 left. So I'm going to say that the whole equation at the end is going to be equal to 45. Let's see, he starts with 150. He's spending money, so we have to subtract. And he spends $35 per video game. So 150 minus 35 times V equals 45. All right, example 2 is going to require some creativity. Instead of having a situation and writing an equation, we are starting with an equation, and then we have to come up with a situation to represent it. So 5x plus 50 equals 120. That means we have 5 times a number, or 5 groups of a number, plus 50 equals 120. They gave an example of the weight of books. They also give an example of saving $5 a week. I think the money one makes a little more sense, so let's read over this one. We have 5 times a number, so we're going to pretend that x represents weeks. You save $5 a week. You want to know the total amount. Since it's the sum of 5x and 50, 120 is going to be our end total. So 5x plus 50 equals 120. You save $5 a week. That 50 still has to represent something, so we'll say we started with $50. So you have $50, you save $5 a week, you're going to end with $120. How many weeks do you need to save for? All right, so that's an example of one situation that could be represented with 5x plus 50 equals 120. All right, last part of the notes today. We're going to write a real-world problem that can be represented by 10x plus 40 equals 100. So we could go the easy way and just think money again. Say we need $100 to buy a new video game console. We need $100. I have $40 currently. If I can save $10 a week, how many weeks do I need to save for to get $100? All right, so that's my example. I want you to come up with an example and write it down. All right, we'll share our examples tomorrow. Let's see how creative you guys can be.